We also have the Aetherists, and these people are, flatlanders. They believe in the ether. They introduced the ether for everything. Now, I do clarify, and I have clarified, that the establishment also believes in the ether. The ether has never abandoned us in the last 3,000 years, because everybody thinks that there is some kind of entity out there, which they call the ether, that either vibrates or serves as the foundation for light, maybe even for gravity. It's the background energy. It's the cosmic background radiation. They've got all these names, the false vacuum, space-time. They have all these names for it. It's known as the ether. It's never changed. Okay, it's always been the ether. Okay, and so I also mentioned a couple of weeks ago what any etherist has to answer. These are your action items. You can't put a comment unless you answer these questions. Otherwise, your comment or your question or whatever you put down is nonsense. You have to tell me what the ether is. You have to define the ether. If you're going to define it, if it's a concept, if it's an object, I want you to point to it. And here are the action items. Here it is. Okay, is it an object? Is the ether an object, or is it a concept? That's the first question you got to answer. Okay, for that you need to know what an object is, what a concept is. So if you don't know what these are, you got to define those words as well. You got to tell me how an object is different than a concept, how a concept is different than an object. And here we have definitions. We work first from definitions. Every word in the dictionary is either an object or a concept. Can't be both. Okay, so either God is a concept or God is an object. God is intelligence, love, whatever, or God is that guy with a magic wand in his hand. Okay, so if it's a thing, it's a man, it's a wizard, fine. Point to him, draw him, make a picture of him, a statue, whatever he is. Show us what God is. If you think God is a concept, just an abstract concept, and that's what you pray to. You pray to intelligence, you pray to love, spirit, whatever it is. Fine. We need to know which one God is. So tell us what ether is. Is ether an object? Is it a concept? If it's an object, we want to see something in front of us with a background. We want to see some shape. If it's a concept, define it. That's how simple it is. Okay, shape, point to, concept, define. Black and white. That's all it is. Okay, so ether is either equal to space or it ain't. It can't be both. So you can't say, you can't use it in both ways. You can't say ether is space and also is within space. No, if space is a container of ether, ether is something separate from space. And if you say that space is ether and there is no difference, well, then you have to tell us that as well. It's got to be one or the other. It can't be both. And that's not very clear to all etherists. Okay, you have these different sects. Okay, is it finite or infinite? I mean, if the ether is equal to space, is that finite or infinite? And if it's infinite, it's not an object. It's not a thing. You can't use it as a thing. You can't say, I'm going to vibrate the ether, because you haven't defined it as a thing. So it had better be finite. But if it's finite, then you got to tell me what's on the outside of it. See how simple it is? Very simple, straightforward. Okay, and does it move? If it moves, it's a thing. Okay, but you can't say a little bit of it moves. You can't say the ether is all this background that covers the entire universe, but I'm going to shake a little bit of it and call that the shaking of the ether. If you're going to shake the ether, you got to move the whole thing. And good luck with that one. You're moving the whole thing, like if it were like this, like if we're a single thing, you're moving it like that. You're going to shake the entire universe. That's a big wave. But if you're going to move a little piece of it, a little region of ether, don't call it the ether. Now you're talking about something else. Now you're talking about the ether made of segments, of particles, of parts. That's not the ether. The ether is the big shebang, the whole shebang, okay? Okay, and again, if it moves with respect to what? So these are the action items that people who propose the ether have to come through with. They have to answer these questions before they can give their presentation. We don't care about their theory at all, really. We want you to identify the ether. Spend 2 years on your ether because we still don't know what it is. People say it's a fluid. That doesn't explain anything. By saying it's a fluid, it's like saying water is a fluid. Yeah, and what is water? What's a fluid? Yeah, I mean, point to it. Okay, if it's a fluid, then it's got to have shape. Okay, and if it has shape, I need to know what's on the outside of it. So don't tell me it's just a fluid. It's a moving fluid, a vibrating fluid, or whatever. Okay, so here's the first individual. He says, the ether, same thing as plasma. Okay, so ether is that plasma, that I guess all those little bees that you see there. Okay, that's the plasma. What is plasma? Plasma is a dynamic concept. That's what plasma is. Okay, and why? Because what plasma is ionization of every atom or most of the atoms in that pile of sand that you see there. So plasma is something that is always in motion because it's ionized, and ionization is a process, not a thing. There is no such standalone thing called ionization. Ionization is a process where an atom loses or gains an electron. And that process requires at least 2 frames of the movie. You cannot synthesize it in 1 frame. Therefore, if plasma is ionization, plasma is also a moving thing. It requires 2 frames of the universal movie. Okay? But he says is inside space. So he's saying if it's inside space, he's saying space is some kind of container. Now we need to know what's outside of space. Okay? We know what's inside, it's plasma, what's outside of space. But then he says space is nothing. So if space is something, now he says space is nothing. You know, space is a container, it's something, but now he says space is nothing. So he's got a contradiction. Why? Because he never defined the word something or nothing. He never defined these 2 words. So he has no idea what something is, what nothing is, and he just uses these words thinking you know what he's talking about, what's going through his tiny brain. Is there part of the universe which is empty? Yeah, between your ears. That's what's empty, okay? He says empty. Empty is what space is. Space is nothing. And he says, is there a part of the universe that is empty? Yeah, let me illustrate what he's missing, why there is part of the universe which is empty, completely empty. Here it is, okay? Matter is the stuff you see. The black stuff is not matter. The black stuff is emptiness. There is nothing there because that is the definition of nothing, which is that which has no shape. Otherwise, you would not be able to see the atoms and or ropes that interconnect the atoms. Okay? They wouldn't have shape. You would have a single block of matter instead of matter being seen in pieces like that if space did not exist, if this nothingness did not serve as a backdrop. That's the issue. Okay, so yeah, there is something called nothing, and that's what you call emptiness, and that's that black stuff there, because you have to define what the word something and nothing is. The stuff you see moving there, that's called something, and that has shape. And all of that has shape. The little balls, which are the atoms, and the atoms that interconnect them. And the black stuff is the nothing, that which doesn't have shape and serves as a backdrop to that which has shape. And nothing is what chisels something, so to speak. Okay, we got that? Okay, so the fellow says, ether is not nothing, it is something. Okay, thank God for that, right? Okay, ether is a soup inside the nothing. Yeah, again, you can't be inside the nothing because nothing is a concept. You can't be inside a concept. Okay? Plasma ether is more concentrated the further you get away from a magnetic field because the magnetic field repels it. So here we have a field, which is a concept that repels the plasma, which is another concept. We have concepts repelling concepts. We have love repelling intelligence. That's what we have here. And nobody's been to the moon. Oh, Jesus. Because, why? The area around the Earth's magnetosphere is full of plasma. Okay, so I guess we can't go through plasma? Is that what it is? I mean, who knows what's going through this poor guy's little brain? But what are these people doing in science? They don't even have the ability to stay within science. They don't have the foundations. They have to take kindergarten 101 before they can come into science. Okay? Okay, here's another fellow. He says, ether can be treated like a continuum. Oh, okay. Because it is made of an infinite amount of objects. Okay, well, that's not what a continuum is. A continuum is something made of a single piece. It's the opposite. See, this was Aristotle's notion of continuum, something made of many parts, because that's the mathematical notion of continuum. In physics, it's the opposite. Continuum means it's made out of a single piece and not made of parts. Pile of sand is not a continuum, even though every grain is touching each other grain, assuming that were the case, or water's touching, every molecule is touching every other molecule. That's not a continuum. That's called discrete or segmented, made of parts. Continuum made of a single piece, okay? He says, most ether theorists have defined ether as being made of many, possibly infinite amount of particles. Okay, no, you can't have infinite amount of particles because infinite is an irrational term. Infinite means you're still counting, okay? If there's infinite number of whatever, okay? So we don't introduce the word infinite into science, or much less into physics. Think the ether is continuous. Well, if it's continuous, it's made out of a single piece. Then it would be continuous. Otherwise, the ether is made of parts, and it's not continuous. It's segmented, made of parts, made of points, whatever you want to call them. Continuums aren't actual objects. Yeah, it could be if it's made out of a single piece. Yeah, could be. But rather mathematical representations of a group of objects' behavior in a single object. Okay, so you're talking about behavior, not talking about structure. A continuum is not an actual fluid because fluids are made from more than one thing. So the guy went completely around in circles, and we don't know what he said. That's essentially it. Okay, here we have another fellow. He says, what? He says, the fish analogy, which I used the other day, and there you see it on the right, is completely wrong. Wrong way to represent any version of ether. Yikes. A light wave should not be thought of as a separate object like a fish. Yeesh. So you can see these guys are so ignorant, so arrogant. They know everything. Okay? Mechanical wave in a medium is merely a behavior of that medium. Okay, so he's saying we have an ocean and it behaves somehow, okay? A wave travels. Wave travels? How can a wave travel when a wave is a concept? You know, you can say the flag traveled, not that the waving of the flag traveled. Okay, so that's when they say, oh, you're doing semantics, Bill. See, you're using word wizardry. No, I'm just repeating what he said. He's saying a wave travels. No such physical object called a wave. That's where the problem is. He's introducing words of ordinary speech or of mathematical physics into science. He can't do that. Okay, there is no physical object called wave. You can't use the word wave in science. But he says a wave travels, he's treating it like an object, through a medium. Through a medium is not an object. Okay, it's a behavior. Correct. A wave is a behavior. It's a verb. That's why we don't treat it as an object, and we can't say that a wave travels. Okay, it says a wave isn't some separate thing inside a medium. Okay, then what is it? It's the medium doing things. So wave is a verb. Okay, it's what the medium does. So you need to identify the medium, and either you identify the medium, you know, the entire ether, for example, the entire ocean, and say that's the ether, the whole ocean, or you identify a portion of it, which is what you're going to be vibrating with, what you're going to be waving. And in that case, you can't say the ocean is waving. You can say the water in some location, some region of the ocean is waving, but you can't say the ocean is waving because that's not what you're talking about. Okay? Looking out onto an ocean with waves coming into the shore, there's nothing there but water behaving. Yeah, water behaves, correct? Now we've got the right word, water. Okay? You can say water, you can say molecules, you can say atoms, but you cannot say the ocean is behaving. Okay, the wave are traveling. Do they exist without the water? Right, you got that part right. So let's go slowly with this all. Let's see if he understands what he said. Okay, here we have it. Here's the ocean. Okay, let's go slowly. Let me remove this one here. Here's the ocean. Okay, single block of water, okay, or matter, whatever you want to call it. Let's assume it's static. We're just looking at a single frame of the ocean, cross section of time. Okay, we're looking at just one ocean. That's all we have there. Okay, one picture, snapshot of the ocean. Okay, now let's go in there and wave something. Okay, here's one wave inside the ocean. That's just one wave. Okay, is the ocean waving? No, water is waving somewhere in the ocean. So we should not talk about the ocean at all. We cannot talk about the ether, which is what the ocean represents. The word ocean here is the word ether. Okay, and they're saying something is vibrating within the ether, the water. We want to know what the water of the ether is. That's the question. Okay, I hope we got the question right at least. Okay, so we had the ocean. Okay, and that's the ether. Okay, now we're going to vibrate a little region of the ocean, which he called what? Water. Okay, so what do we call a region of the ether? That's the million-dollar question, because here you have many waves. See if we can put this up here. That's many waves. That's the ocean with many waves, each one with a little region. Okay, but you know, this is the issue. The issue is here we have a single region of the ocean. He called it water. He says you can't have wave without the water. Correct. We don't care about the word ocean. We don't care about the ether. Now we're talking about the piece, the segment, the region of that ether which is moving. In the case of the ocean, he calls it water. We need to know what water is in case of the ether. That's the million-dollar question. Okay. Okay, so if you have many waves, like you just saw, this is what you have. There you have the ether. You have all these regions of the ocean, and they're vibrating. And when they say, look, it's the ether is vibrating. Well, no, the ether is not vibrating. What's vibrating there is every region of the ether is vibrating. You see the water molecules, so to speak, of the ether, which are vibrating. We need to know what the water is that you call the composite of which we call ether. Okay, and so here, if you look at one of those regions, you expand it, this is what you would find. Okay, they say, well, the vibration of the ether. No, that's the vibration of the water within the ether. And again, you have to tell me what the white dots are. You can't call that ether because you're talking about a region of the ether. And for that, you need to define. That's what you need to do. You need to tell us what the physical object is. And until you can identify the water of the ocean, the water of the ether, right? You can't even start your presentation. Okay, another fellow, he suggests an experiment. Okay, this is what they there is an easy way to solve this. Okay, good. Go to space with a clear air-proof, waterproof ball. Okay, open it in outer space and close it back to have the ball filled with ether. Okay, bring the ball under water and open it. If a bubble forms, then space is a medium, ether. If you see fume waves, then space is a gas. If nothing happens when the ball fills with water, then space is a vacuum. Okay, okay, so this is what people have going through their brains. They have all these things that they think they can prove through an experiment, what the space is out there, which they call the ether, which they say is within the space, and that space is a container, and they don't know what's outside of this container, giving it form. They talk about infinite particles. They say the space is infinite, the ether is infinite. Then they say, we're going to vibrate the ether, and they're not vibrating the ether, they're vibrating the water within the ocean. So they have all these contradictions. They never resolve these. They never, and this is a question of rationality. You have to resolve these issues before you can give your presentation, before you can talk about the ether or anything else. But they don't do that. They just go directly in there, and if you question these things, you're doing semantics, Bill. You're doing philosophy, ontology, whatever it's called these days. Okay, here's another fellow. Okay, let's get him up here. He says, light doesn't require a medium. He's saying, we don't need this ether thingy. I guess he says they proved the non-existence of the ether, okay, of this medium. There is no medium out there, okay? And so here you have light, and we talk about the motion of light. In fact, he says, light is moving the fastest in a vacuum. Light slows down in a medium. Okay, that's what light does through the water, through the ether, fine. But he doesn't tell me what light itself is, but he says it doesn't require a medium. So he's talking about light moving, and how can light move if light is not a thing? If it's not mediated by something, okay? If light has no medium, what is it that is moving? Nothing? Is it a concept that's moving? So this is the issue. You have to define the word motion, and that's why this guy is not even in kindergarten physics. He doesn't understand what motion is. You need two locations at least of a medium to talk about motion. That's the definition of the word motion. Once you have that definition, you cannot say light does not require a medium, because then what is it that is moving? What is it that occupies two locations? What occupies two frames of the universal movie if there's nothing there? Okay, if it's a concept, or who knows what he's got in his mind. And then, yes, you see there the little c is equal to frequency times wavelength. That's the equation of a rope. Okay, that's what the mediator is. That's what's moving. That's what's vibrating, in this case, torquing. Okay, and all we have is a difference between segments of the rope. For a given length of rope, you have more links, and the links are shorter. And if you unwind the rope, well, then you have fewer links, and the links are longer. And that's what that equation represents. C equals frequency times wavelength is number. C is equal to number of links, and wavelength is the link length. That is the equation of a rope. Only a rope can simulate that equation. Okay? So that's That's where we're at. And here you have a definition of what an object is and what motion is. Okay, an object is that which has shape. You need to have shape. And so to say that light has no medium or is not mediated by anything is irrational, because you're going to talk about motion. And so the question is, what is it that moved? Motion, two locations of an object. And there you have a film of the movement of something and a film of the movement of nothing, which is what this fellow proposes. Okay. So again, I don't know what these people really have in the back of their minds when they talk about light moving. How can light move if it's not a thing? You need to have a thing to conceptualize motion. And here you have, let me make this bigger. Give me a second here. Here you have why the rope is a good model for light, because light has that equation. The velocity of light is 300,000 kilometers per second. Okay, it's a constant, and it's a constant between any two atoms. It doesn't matter what object it belongs to, and it doesn't matter what light goes through. Between any two atoms in the universe, at least in the known universe, right? Light has the same speed, the same torque, because all you're doing is changing frequency in exchange for wavelength. If frequency, meaning more links, are there, then the links are shorter, and vice versa. If the links are longer, you have fewer links. And what you have here is, you can see white light coming in there, and again, this is just a picture of what happens through a prism. When light goes through the prism, you can see that between atoms, the links are of different wavelengths. There are different number of links. And what comes out is all these colors. And what are colors? Well, they're different link lengths and different what we call frequencies, meaning number of links. Okay, so for a given rope length, right, you can torque it more and torque it less, and you're going to get different colors, meaning different frequencies. And this is easily shown. With a rope model, it's perfect. There you have few links. I don't know how many are there. What is it, 2 or 3, right? Now we're going to torque it some more. It's always the same piece of length. That's all the rope I've got, okay? I'm not introducing more rope in here, okay? Now you have more links, and each link is smaller, or shorter, okay? And now we untorque it. Now the links become longer, and there are fewer links. And what we have, this is the equation of a rope. C equals frequency times wavelength. It's always the same amount of rope. Okay, so for this given length of rope, you can simulate why light always is a constant between any two atoms. All you did was change the number of links. That's it. Okay, that's the theory. Now, some people say, well, if you torque it more, the rope kind of shrinks, right, and becomes shorter overall, right? The rope is a little longer if you have the links like this, right? The longer links. Then if you torque it, it tends to pull all the links closer together also. And yeah, the answer is very simple. Remember how the atom is constructed. It's constructed by these same threads. So the atom slides through these threads, and the threads are being fed into the rope. So the slack is taken up from the atom, which is taken up from another rope, which is taken up from another atom, which is taken up from another rope. When you pull on a rope, in this sense, you're pulling on the entire universe. That's what you're doing. The atoms are sliding along the ropes, okay? And because the ropes construct the atoms. So there's no mystery. The rope can become a little longer, a little shorter when it torques more and torques less, because it's borrowing slack from atoms which are buying it from another rope, which are buying it from another atom, and so on down the line. Okay, here we have another fellow, and he says all of those have motion because they are all made out of moving molecules. So I showed the other day how solid, liquid, and gas is something you point to. There you have a liquid. We took a snapshot of it. Does that have shape? And the answer is yes. Gas, you take a snapshot of gas, whatever gas, if you could see it, and it has shape. And same with a solid. And this fellow is trying to say that plasma and fire also have shape when you take a snapshot of it, and that nevertheless, fire and plasma have stuff that's moving in there. They're dynamic entities, you could say. But for that matter, so is gas, liquid, and solid, because they are made of atoms which have electrons, and the electrons are also moving within those atoms. That's his argument. Okay, he says all molecular objects are processes by the same standard. Liquid and gas embody motion too, fluid motion. Well, again, one of the problems with these people, they've never taken high school physics or kindergarten physics. That's why I look at it. Okay, so let's educate this fellow. Let's go slowly because they have problems understanding all this stuff. Okay, here you're going to teach the Klingon your language. You point to a tree. Are you thinking about the atoms that comprise the tree and whether the atoms and the electrons within the atoms are moving when you look at the word tree? No, you point and you say tree. Tree is that thing there. You can take a snapshot of it. You can make a picture of it. You can bring a mock-up of it. You can bring the actual tree. You're not thinking of the atoms that comprise the tree and whether they're moving or not, or whether there's a wind that moves the tree. The word tree represents a static concept. Okay, it is a static concept. The word tree, the word, right? Tree you point to and you say tree, it's an object, and you're not thinking of what it's made out of and whether it's moving. Okay, the word tree does not embody motion. We got that? I know it's kindergarten stuff for us advanced people, but for some of these people, it's a big jump in their intelligence, in their understanding. Okay, here now you're going to teach them the word table. Okay, you're going to teach them the word table. What is a table? Well, a table is what I pointed to. It's that thing over there. I point and say table. That's the way you do it. And are you thinking about what the table is made out of? Whether those atoms are moving, the electrons are moving within atoms. No, you're not thinking about any of that. The word table does not embody motion. The word wall, the word rock, none of these embodies motion in the word rock, in the word table, in the word chair, wall, etc., ground. Those are static concepts. The words are static concepts. They don't embody any motion. There is no motion involved in there. No action. Let's go now to another. We're going to teach the Klingon another word now here. Okay, let's find out. This is the word. Went all the other to the other side. Give me a second here. Let me get it back. You're going to teach them the word ion. Can you put the word ion in a single frame of the movie, of the universal movie? And the answer is no. You point and you say, well, that's a ball with a plus sign over it. What does it stand for? Well, I mean, there's two objects there. There's a plus sign and a ball. And you have to explain to him that, well, something's happening. Okay, what is it that's happening? Well, in order to explain happening, behavior, action, you need two frames of the film. You need motion. Okay, and that's what you got to show them. You got to say, look, what happened is the atom lost a marble, lost an electron, lost a ball. So, but for that, lost, got rid of, is a verb, is an action. There's something going on. You need two frames of the film, of the universal film. You got to show first one frame where the ball is there and the other one where the ball is no longer there. That's an ion. An ion means something happened to the atom. Ion is not a standalone object. Ion is something happened to this atom. That's what the word ion means. And that's what the word plasma means. You can't point to plasma because plasma is ionization. Ionization, you need two frames of the film because you got to explain to the Klingon in this case that the atom lost an electron. For that, you need two frames of the film. That's what plasma requires. That's what plasma is. You can't point to plasma because plasma is a verb. It's an action. It's a process just like fire. The word plasma embodies motion. The word stone, the word table, the word ceiling, wall, rock, tree, none of those embody motion in the word itself. The word plasma does. The word fire does. The word wind does. All these words embody motion. You cannot have wind in one frame of the movie. If you have wind in one frame of the movie, you have air. So far you have air. So far you don't have wind or hurricane or tornado or vortex. Okay, we got that? This is kindergarten stuff. Okay, so if you don't understand that, you flunk kindergarten. Okay, kindergarten physics. Okay, one fellow suggests that you can pull with a corkscrew mechanism. He says, what can you throw at something that will attract it? Notice that he says throw. Okay, he says, what can you throw at something that will attract it? He says a corkscrew, cyclone. Okay, because he's saying that action at a distance, you can throw like a stone at something and attract it. Okay, that was the issue. He's trying to explain gravity by throwing something one way. And he's going to say you can do it with something like a corkscrew, which is more or less like water running down a drain. It says radiation moves in outward spirals. Radiation moves? Radiation is a concept. There's no physical object called radiation. But he doesn't understand that because he hasn't gone through kindergarten physics. Gravity is a reciprocal force, just like water spiraling down a drain while air is simultaneously pulled upward out of the drain. All motion is two-way. Okay, so the issue here is that water rushing down a drain, water is made out of molecules, they're going one way, okay, and it's you would have to have infinite water for that to happen, okay, for it to go always forever in one way, okay. But that's not the same thing as the corkscrew that you see on the left. The one on the bottom left, you can say that that's already connecting two ends, source and target, okay? That's different than something being thrown at something else. So when he says when you throw something, he's talking about the water going through the drain. He's not referring to the corkscrew. But for him, he sees nothing different between the corkscrew and water rushing down the drain. These are not the same scenarios. Because if you're going to use the corkscrew, then you're talking about something like the rope, where something is already connecting physically one object to the other. Okay, that's different, and you can't use words such as radiation or spiral or vortex or anything like that because those are not physical objects. You got to tell me what physical object is torquing. In this case, I'm showing a corkscrew, you know, the mechanism there. It's a mediator, no problem. But then you have to show that and say, what is that thing that you're pointing to there? You cannot talk about water rushing down a drain and say that's the same thing as a corkscrew. But this fellow doesn't understand these basic things. They're so smart, they're so arrogant, you know, they know everything. So they don't even understand these basic things. Okay, one fellow says, why can't I use black magic as my mechanism? Okay, why can't he? I mean, can't we? Explain with black magic. Isn't that a mechanism? The answer is no. Black magic, no mechanism at all. Because black magic, you cannot see the mechanism. You're just showing what I show there. A spoon over here and it falling to the floor. And you cannot tell me what caused that spoon to fall to the floor. You know, you see the spoon, see if I can do this, okay? You let go of it, and it falls to the floor. So it falls, and you can't see the mechanism. And so black magic is no mechanism at all. Make a movie of your mechanism, and then we'll know whether black magic can pass the test, okay? Okay, and finally we have a fellow who, also a flat earther, who brings it into the topic of extinction, which we're very close to. I mean, here we have the war in Ukraine and all this stuff, right? Inflation, there's going to be more unemployment, the interest rates are going to rise, I guess. Who knows? We're going to have a great couple of next years, okay? But here this fellow says the following. He says, you guaranteed a bold prediction that we are the last generation of humans. No, I made no prediction, okay? And again, this fellow was educated by the establishment. He talks about prediction. He uses these words such as prediction. And so he doesn't understand the difference between a prediction and an explanation. That's where the problem starts. Despite the best mathematical concepts, not even economists can make reliable predictions in either the short or long term. Yeah, we're not talking about predictions at all, and he doesn't understand that. A mass extinction event involving a collapse of the food chain triggered by the value of money going to zero. Yeah, ergo, no farming because no money, global starvation inevitable. You do know money is no object. Yeah, no kidding. Money is a mathematical concept. Hey, he's a smart fellow, okay? Economics doesn't deal in explanations. Economics is not science. Poor fellow. Again, it's because he doesn't define his terms, so he thinks all of this is a prediction. And all I can recommend to anyone who uses the word prediction, here it is, synthesis. You have to do Extinction 101 before you do Extinction 102. First, you got to tell me past extinctions. Explain past extinctions. Give me the mechanism of how species in the past, which are already in the ground, their bones are in the ground, their fossils are there. You got to tell me how those became extinct first. Okay, once you have a mechanism, a physical mechanism, once you can explain how those animals, plants and animals, etc., in the air, on land, and sea disappeared, okay, once you have that, that's Extinction 101. Now you can tell me, now you're an expert to tell me something about human extinction. And no, it's not a prediction. It's called an explanation. We're explaining the mechanism of how humans are going to disappear. We're not making a prediction. A prediction is on the 1st of May of the year 2030, the last human is going to die. That's a prediction. We don't do that here. We can't tell you when the last human's going to die. All we can tell you, which is extinction of the human race, right? No, we can tell you the mechanism, what is going to cause the extinction of man, because Mother Nature uses the same cookie cutter on all species. And she used this mechanism on all species in the past. Once you get the cookie cutter, once you know the mechanism, you apply it to man and see if man can avoid that same mechanism. And it turns out it's economics, science. Yes. And so there, first you got to take Extinction 101 before 102. It's not a prediction, it's an explanation, okay? And mechanism of mass extinction is economics. That's why economics is an explanation. All animals have economics. Economics is the management of resources. All animals manage resources. They manage one resource specifically. It's called food. All animals manage food, and that's known as economics. And when food runs out, the animals run out. That's more or less, in a nutshell, a mass extinction. And the same thing will happen to man. Man will disappear in a mass extinction, not in a background extinction. We're the last of a dynasty of hominids, monkeys, whatever you want to call us. Mass extinction, disappearance of an entire food chain. That's what a mass extinction is. And we're due for extinction very soon. Okay? You got to explain the extinction of the animals in the past. Then you can talk about the extinction of man. But these people skip that step because they know nothing, absolutely nothing about paleontology. They know nothing about how animals disappeared. They don't even have an idea. They just borrow from the establishment and they say, oh, I think the dinosaurs died when a comet hit the earth. And that's all they know. They don't even know who the animals of the Permian are, or the Triassic or whatever. They have no idea whatsoever. And they say, oh, but I'm an expert in human extinction. I know humans will never die, or if they die, they'll die because of what? Climate change, disease, what is it? What other ones are there? Peak oil. You know, they have all these. Maybe a comet will hit the earth. Okay, so they know nothing about extinction, but they're experts.